I'm gonna talk about the high school math 2 big project part 3, and here this is my big project. So here, let's go. Introduction. In this project, I'm going to do about the shapes like rectangle, triangle. In this project, we do like be including the tan cosine and other things like to find like missing sides and all those things like vocaps and finding the volumes and other things. Okay, so here's the method. Method is basically the same thing that I just did in the result in the task, and it's just a summarized thing that I just did. Okay, so let's start with this one. So here's the thing that I should do, the task. So isosceles triangle, and this triangle is triangle have two the same side and two the same angle. As you can see here, it's two the same side and two the same angle. Median of the triangle is a midpoint of 2 points and that connect to the opposite vertex. You see here the point that connect to the vertex, that's called median. And the centroid is the middle point of this intersect. Midpoint is the line segment. Is the middle point of the line segment, and the perpendicular bisector of a segment is the line that separates one line to two equal half. And the angle bisector is the line that separates one angle to be two equal half too. And complementary angle is two angles that add up to 90 degrees, as you can see here. And supplementary angles that add up to 180 degrees. Corresponding angle is the same angle that in different places here. Alternate interior angle is the opposite congruent angle that is inside. You see that? Alternate exterior angle is opposite angle that is outside. And the opposite angle that congruent, and it happen when two lines are crossing each other. So when two lines cross each other, and we'll get a vertical angle. And the transversal is the line line that pass through or cross two lines. Parallel line is the two lines that never meet with each other here. Vertex is the point that two segments joins, and point is just a dot. And the line formed with 2 points never ends. Segment is the segment formed by 2 points and ends at the point. Ray is the start with 2 points and it stops in one side here, and another side just goes to infinity. So task 2 here. So we must construct a quadrilateral and prove its parallelogram. So here I draw a quadrilateral, and as you can see I use the slope formula to find the slope. So here's 2 over 5, and this side also 2 over 5 so it's parallel here, and these two sides are also parallel. So I can prove that this is a parallelogram. And next, construct a parallelogram. So here is a parallelogram, and prove it's rectangle. So we do the same thing. The only different thing is that we just need to times this side with this side, and then if we get -1, then it's a rectangle, and I get -1, so it's good. We are getting rectangles. Draw a triangle and dilate by scale factor 2.75. Okay, so here is the dilate version, bigger one I made here, and I can prove it's a congruent because all the angles are the same, but just the size because I dilated. So yeah, and here we just need to rotate it 45 degree counterclockwise. So we go left, and then we can prove that it's congruent because all the angles are the same too. And next task is we find the width of the river. So we draw a triangle first, and like we have two sides. We have one side here opposite, the adjacent side, the theta. And what we do is we use tan and use this formula and put it in, and what we get is 2.64. And so it's the length of this side, and that's the width of the river, and that's how we find it. Next is you go into a vacation to kayak, and it's like you got a tree blocking your view, so we want to cut it off, but you scared you hit your house. You just want to make sure it doesn't hit your house. So what you do is draw a triangle, and then here's the meter, how how long is you do it with the tree. Here's the data, and you do the same thing here. You put input the information, and you found the answer is 3.12. So the tree height is 3.12. Therefore, it's not gonna hit your house because your house is 5 meters far away. And last task. So in this task is we must find the lowest aluminum that they can use. Okay, so the red lines are the possible answer that can fit the 200 centimeters cube, and we must find the lowest used with aluminums. I try to put random answer and try to find the lowest use the aluminum, and I got the number 189 point and then comma 335, but it isn't the close enough. So I searched the internet and I saw this is show when it's the lowest point. So the final thing is 2r equals to h. So it just means that when the h is the 2 times of the r, then it's the lowest surface area that used. So the lowest aluminum that can be used is when is this answer, because I put it in the decimals and it shows me. And then let's come to the conclusion. The discussion. So in this big project, it's like harder than last year, but overall, yeah, I'm still fine with it. It's okay. And the conclusion: this quite a big project is about proving, analyzing, and answering different shaping, finding missing part of shapes. Also, in this project, we need to provide congruent and parallel between the shapes. We need to able to transform it, dilate, rotate, and many more. And also find the area of volume of different 3D shapes. Let's come to the standards over here. So in these standards, I know how to find like congruent things. That if there's congruent, there's 5 ways to do it. First way is like we can see if they have the same slope. Second is like perpendicular, and next you like perpendicular to the the third line if they are congruent, and the third is corresponding angle. Fourth is alternate interior angle congruent, and the last is the exterior angle congruent. I learned this because this is the basic knowledge that engineer needs in the future. And in this standard, I learned about the theorem about triangle. If I know that every triangle side angle added together will have 180 degrees, and isosceles triangle are congruent, and it has 2 equal side and angle. And I learned this because engineer needs it in the future. Yeah, it's the same thing. And in here, I know how to prove the theorem about the parallelogram. I know how to prove it if it's a parallelogram. So for example, like if you want to be make it congruent, and you can check the SAS, ASA, and SSS. We can use this to check if it's congruent. And then this is like because engineer needs it in the future. And this standard, I learned that how to dilate and dilate the scale, like the picture, make it bigger or smaller. I know I learned it already because I already showed you one example upstairs, and I learned this because we can use this skill to change the size, the thing that we want, make it bigger or smaller. And next, I learned the standard with find the similarity of the triangle, and even when they are transformed but they still have the same angle and distance, we can solve the problem in the many ways. I know I learned it because we already done a assignment, because for example, we're given a triangle ACB, and A equals to 10, B equals 70, and C equals to 100. Another triangle is EGF. E equals to 10, G is 70, and F is 100. We can look closely and we can see that they are corresponding to each other and it's similar to this. I learned this because this use stabilize a bridge in the future. Okay, so in this standards that I learned that the transformation it have the reflexive property, dilation, translation, rotate. I know how to do this because I showed the example already at the top. Yeah, So I learned it because I can do many things with it in our life.